All right. Hello, Tech Confluence. This is AI Trust. I'm Gabe Hamilton. I'm a staff software engineer at Pagoda. And Pagoda works on different sorts of blockchain technology. So a lot on the Near protocol, but also different protocols, Ethereum and Polygon, several others. And when I was switching from my previous job into blockchain, I'd worked the previous 7 years at an AI healthcare company. A lot of my friends were puzzled. They're like, well, AI is so hot. Why would you move out of AI? We're trying to get into AI. Well, a couple of reasons. One, I moved into an AI and blockchain ecosystem. So it wasn't just blockchain. And two, there are a lot of great overlapping use cases. And we're going to talk about one of those today, which is AI trust. Okay, so we'll start off high level. And this is a research talk, some predictions about the future. But it's also a how-to talk. So we'll have real examples, real use cases, and how to implement them. It's detailed, but if you know how to use ChatGPT, know a little bit about blockchains, should be able to follow along. And I'm going to give this talk next week at a blockchain conference. So there's a few blockchain things I was thinking about here, but we'll stop for some questions and can answer any questions people have. So after the high level, we'll go into some detailed examples. A lot to cover. Go kind of fast, but this will all be online, both these slides and the recording, along with tons more resources. Okay, so I'm actually here today from the future, as you can see, obviously the future, there, right? To tell you about AI and blockchain. So it's a future where you've got agents that are doing lots of tasks for you. So super futuristic, like later this year, as Lee was just talking about, kind of the things he was getting into, where you've got an agent that can do more complex things for you. It's not just answering a question. It can run autonomously and tie into lots of different systems. So blockchain and AI, it's a hot topic. There's a lot of articles out there about blockchain and AI. They're one is centralized, one is decentralized. One's a black box, one is transparent. Great. So, one's tall, one's short. Are they just walking down the street, or are they complementary? Are we talking like Nikola Jokic and Jamal Murray, like totally different skill sets, but together they're magic, or just two people walking down the street? So, yes, they're very complementary. Fortunately, they are like the Nuggets. They're magic, and we're going to dig into exactly how. So first, a little bit of orientation. AI is a big space. This talk is not about the large language model layer. So it's about the layer that you all build on top of large language models. So agents that do things for you. So it's not about provable inference or about the training data that's going into those models or fair use of that data. About things that you all will tend to build. Even within that agent layer, we still need to narrow down a little bit. So there are lots of great things that you might use a blockchain for with an AI agent. So identity delegation, payments. I hear cryptocurrencies are a big thing. So payment delegations, budgets, those are great use cases, but we're not going to talk about those today. This is just about AI trust. Okay, can I trust this agent? You've got a great agent that you've built or that you've found. You're like, wow, this looks so useful. Can I trust it? Did it find me a good deal? Or did it read a bunch of ads? It's like, oh, you're looking for a vacation. Great, I can plan that for you. I've booked it all for you. It's the hottest thing around. Vacation in Arizona in the summer. It's going to be great, non-refundable. Well, okay. So what went wrong there? Why did that agent not work? So that's what we care about. Can I trust it? How is it behaving? How do you monitor that? So right away, we can see that we're going to need to record what an agent is doing, have some insight into that. And maybe we'll want to limit the sources that it's using. So the more we record, the more opportunity we have to monitor that and say some of that data that it fetched, that it's acting on, was redacted. Maybe it's a news story that gets redacted. If we've recorded that, then we can have something that's checking and say like, okay, great. It had invalid data in, so obviously made an invalid decision. We need to go and undo that. And the more complex the agent is, the more likely we're going to want to do something like that. Okay, so when we're fetching data, that might be a web search. It might be a database query to a database at our company. It might be APIs that's reading. So that's all data that we want to be concerned with. And we might record what that source was, when it did it, obviously, some characteristics of that result, permalinks to the web pages that it fetched, that it then digested. And ideally, some reputation scores. We can say like, okay, great, these are reputable news sources. These ones are interesting, but you should weight those lower. Or maybe you want to just limit it to high reputation data. Next, we care about the integrity of the decisions that it's making. So how did it book that trip to Arizona? What led to that? How do you debug that? So we want to record some of the intermediate states. And with an agent, often you are having it make a lot of large language model calls. So you're going to have it think for you, like what should it do next? What's the next step? We saw in Lee's talk some of those chain of thought and tree of thought prompting. So how did it progress through that? Where did it get lost? Or where is it making good decisions? So we can record some of those intermediate states. That's great. Obviously, we want to record the outcomes. It booked this trip, it did this. Those are really important things to measure. And then any user feedback. So if we can put in places for the users to rate intermediate steps and outcomes, that's great. We can collect that data. ChatGPT is certainly collecting a lot of that and letting you do some of that. But we want to collect that in our agents, so we have access to that data as well. And anytime someone adjusts the intent, they're like, oh, okay, that was close. It's asking the user, is this kind of the result you wanted? We want to capture if they adjust that. And they're like, oh, almost, but I'd rather go to New Mexico, things like that. So really good things to capture. We can start by writing logs. So we'll write these out in logs. All the information we capture, the logs can be private. So they can be just on your machine if you want. And we're used to having somewhat of a log of a chat conversation. If you're using ChatGPT or something, you ask it a question, it answers, you've got sort of that history. So we can record that sort of thing, but often as we build more sophisticated agents, it's going to be working a lot more autonomously. You're not going to be directing it for every little thing it does. So you want some of those same logs to be recorded so you can go look at them later, even if the user is not actively involved in each of those steps. Certainly, if it's taking actions for you, you want more detail. If it updates your retirement portfolio for you, maybe that's really great. But you probably want to be able to review that data. And often you'll be able to ask it, okay, what changes did you make? But if there's a bug, you want to be able to go and review that raw data and make sure that it's really correct. So private blockchains. So you might all be familiar with some of the different public blockchains like Ethereum or Solana or Polygon, which they're like databases where they're programmable and they're distributed across a lot of different nodes. So they're decentralized. A private blockchain is something that a company might run themselves or a group of companies and allows, it's kind of a shared database basically. So it allows each of those different companies that are involved to have their own copy of that database that's all in agreement. So private blockchains are really powerful and they're coming to more and more companies. Either as companies enable the ledger database features of the database they're already using. So if you're using SQL Server, you can kind of just turn on some of the blockchain features. Or as consortiums of companies and working groups start to share more data, a lot of them are realizing that private blockchains are a great place to record things. So I've seen some nice use cases where coffee growers in Colombia want to trace the provenance of their product all the way through the consumer. And so, there's lots of different players involved. A private blockchain that they all can use has been a great solution for them to record this data so you can prove that it, was fair all along the way and everyone has access to it who's part of that consortium. So this is a great place for all of your company AI agents to coordinate. You've got lots of AI agents you start building in your company. They can store data on your company's blockchain. So public blockchains, the ones that you might be more familiar with. So the reason you use a blockchain instead of a database is settlement between multiple parties. And back on the private blockchain side, JP Morgan is building tons and tons of private blockchains for all these different settlement use cases that previously, they had one central database, but now all the companies can share in the database. But there's lots of public cases for settlement. And for things like carbon credits, where you have a market in something, lots of different players. You want a public exchange of that. People use blockchains for that sort of technology. So another reason we use public blockchains is because open source wins. When you have things that are open and transparent that people can build on, that really tends to beat out a lot of other solutions. So it's really powerful. A large publicly accessible trust network is going to be a lot more powerful than a private locked away trust network. So that's a really great use case for a public blockchain and for writing this agent data to a public blockchain. We'll get literal network effects. Okay. So let's say you build an agent, a vendor researcher. You might do that on OpenAI as a OpenAI assistant. So it might be a custom prompt, as was talked about in the last talk, where you're constructing a prompt. It might be a whole page worth of text about instructions for your agent. But you might get a little more sophisticated. Maybe you use LangChain. That's what I like to use for building agents. And you give it access to a couple of tools. So web search, maybe API. You want it to be able to go and talk to the Dun & Bradstreet database of business information, or maybe the Better Business Bureau. So all of those are useful tools that you might use in your agent. And there's tons of frameworks that people are putting together for building agents. So if you go search online, you'll find lots of different ones. Agent GPT is another one. And every day when I go look, I find more and more. Okay, so we create a vendor researcher. We want to be able to use this whenever we're looking at a vendor for our work. Like, should I use this vendor? Should I use GitHub Enterprise as compared to other products I might use, as opposed to Bitbucket or something? So great, it's working for you. It's real useful, fetches this data. What sort of data do we want to store with an agent like this? Well, we can store the sources that it's using. We're like, great, it did not find anything at Dun & Bradstreet. Okay, that's weird, but that would be useful to know. If we can get citations from the different pieces of data that we are fetching, that'd be really good, so that we can go back and check those if we need. Maybe we're doing a lot of vendor research and we just kind of spot check a couple of the instances. And then, whatever scoring it's doing. So if our prompt asks it, please take all this information and score it along these different dimensions, that's probably a good thing to record. What was the output of it? And, any internal logic we have about its scoring. Okay, but maybe we're going to get a step more complicated. And, really useful software takes in information about the world and processes it in some way and has some outcomes. So we're used to that with sophisticated software in different areas, but it's going to become more visible as we're building agents that specifically do that fetch some data, process it in the way we've asked it to, and have an outcome. So we call these type of agents world model agents. They're modeling some portion of the world, vendors or whatever it is we're building. So we saw pulling in state. That's what our vendor researcher was doing. But for a more complex example, maybe we have an RFP processor. So we've got a request for proposals, and our agent is going to process all of them. So this, maybe it's even split into a couple of different agents, but it's interacting with humans. It's a really complex coordination case. So, I've got the wrong input there. Still telling it to evaluate GitHub Enterprise. In this case, we'd be giving it a lot of instructions about how to take each of the proposals and evaluate them and what the different steps are. So maybe it's going to take all their proposals, score them, and the top 20, it's going to send on to humans to make the final decision. Or maybe it's going to ask every person who works for the company, hey, please score this particular question. What do you think of this? Maybe it can gather some data and score it, but it can't evaluate how trustworthy the vendor is based on past projects. So it might ask someone. So some handoffs. Okay, so we might give it some retrieval augmented generation tools to be able to pull data out of databases. Might give it some workflow coordination tools to be able to ask humans for things. And maybe it can go look at some past projects and pull in data for those. So nice complex case, the kind of thing that you may all be involved in building in the next couple of years. And if we can store a lot about how this process is going, then we can go back and look at it. And if we can store it somewhere like a public blockchain for some of these steps, maybe we're writing everything we can to logs, we're writing a lot of the process out to a private company blockchain, But then we're exposing a bunch to a public blockchain as well, so that all the vendors can follow along, be like, okay, I've seen that my proposal has been accepted. It's got some initial scoring. It's waiting for this. This is what the final result was. All those things are really useful to expose. And the more you can expose some of that, the better you can observe the process. So maybe one of those evaluation steps has a bad bias. That LLM does a terrible job of scoring all the different proposals along some dimension based on all the data it's been trained on. The more eyes you have on that, the better you have a chance of being able to see that and someone saying like, hey, what the heck's going on with that step, and fixing the whole system. We touched a little bit on how we do some of this work, but the place that I like to do a lot of this AI trust work is around LangChain tools. So LangChain is a framework for building agents. It's open source, and you can pull in whatever models you want. You can expose tools to your agent, and you can have a lot of step-by-step processing. So for this AI trust, that's a good opportunity to build tools that store data. So like, great, here's a tool for storing data on a private blockchain or a public blockchain. So as a developer, you can call those tools and say, great, I've got a evaluation step. Let's go ahead and write that out explicitly. That's something a developer would be involved in. We can also wrap tools. So we can say these types of tools are all pulling in state. This is a web search. This is querying a database. These are all pull in state type of tools. What are some standard types of things we want to write out from that? So with those sort of wrappers, we can give that to developers automatically. A lot of the LangChain tools correspond pretty well to OpenAI functions, so you can pull some of those straight into OpenAI if you're building an OpenAI assistant as well. All right, so far we've talked about kind of best effort types of features. But one of the really nice things that blockchains give us are the ability to prove things. So we want our agent to do something, to make this purchase, for instance. We can gate that on whether or not it has done some other tasks. So maybe it needs to at least write out some compliance information on chain, or maybe it needs to have gotten approval from a person. So we can construct a proof for that. And we allow our agent to call just our gated function. So we say, okay, you've got permission to call this gated function, but that function requires that you submit a signed message that says, I want to have this gated function call this other function for me with these parameters. The kind of thing you could do there is you could say, great, that function call with those parameters, we can hash that, and then we can send it to an approver. Say like, okay, great, do you approve that your agent should be able to call this function with these parameters? Great, that approval gets written on chain as well. So that's what gets submitted to the gating function. The gating function's like, great, I can see that you want to call this, and that was approved by this person. You, agent, may approve that, or may call that. So that's really powerful. So we can really constrain what our agents can do in various ways through mathematical proofs of what we're going to allow them to do. Okay, privacy, very important. So public blockchains are transparent. That's really great, super neat. But the flip side of that is privacy. We want a lot of this to be private. We don't want to know that this person is searching for a vacation in Arizona and this person is searching for something else. So there may be things that we want to write out explicitly. As a developer, we might say like, okay, these steps in the RFP process explicitly get written out. But for the data that we're going to automatically collect for trust, we want to make that anonymous and non-identifiable. That's okay. There's lots of things we can do. We can generate a random session ID for each of these sessions. That's part of what gets logged. And we can write out a lot of information about the usage of the tool that's still anonymous. One thing we can write out about the large language model calls, instead of saying, this is the response, we can write out information about the probability distribution of the tokens that it returned. So we can say like, great, this is how confident it was, how perplexed it was in the different tokens that it returned. And so that we can look and see, great, do those correspond to certain outcomes? And it gives us a little bit of insight while still being anonymous. Certainly error rates, anonymous user ratings, all useful things to store automatically and anonymously. So alignment with AI be a long and continuous process. We're all aligning with each other all the time. Where should this conversation go? What is our team working on? What should our company do? Like state and local, national governments. There's lots of alignment that humans do. and throw in lots of agents, great. We have a lot of experience of aligning with people. We can apply those same things to aligning with agents, getting our AI agents to do the things that we want. In fact, we all have lots of experience with getting software to do what we want. And some of that's the same process. In some ways it gets harder as we can talk to our software. Some ways it gets easier to communicate with the software. But with humans, a lot of that agreement, whether it's two people or countries, is still kind of the same process. You apply some of the same skills to those same things. I think that's the same of AI, that as we practice our skills for aligning our agents, we can use those at higher and higher levels. So hope this talk will help you develop some of those first levels of alignment with your AI agents that we'll be building in the coming years. Thank you.